Hi everyone. Today we're going to learn how to solve radical equations or equations that involve rational exponents. Our learning goals are to solve an equation that has a rational exponent and to solve a simple radical equation. So we've learned how to solve exponential equations, and those are equations where the variable or the x is in the exponent, and we use the method of common basis for this. So my question is, how would we solve an equation where our variable is not in the exponent, but we have an exponent that is a fraction? Okay, so that's what we're going to learn how to solve today. I remember when I learned this in high school, I thought it was really cool and I thought of it as a superpower. All right, so x to the power of 1/3, and I want to eventually just get x equals. So, really cool. Remember, our main rule of equations from grade 9 is whatever you do to one side, you do to the other, and it keeps it balanced. So if I raise this side to the power of 3, then x to the 1/3 to the 3, using the power to an exponent rule, it means you would keep the base and multiply the exponents. And you can see that 1/3 times 3 gives you x to the 1, or x, okay? But if I raise this side to the 3, I have to raise this side to the 3. So 4 to the power of 3 ends up being 64, so x is 64, right? So I feel like that's a really cool way to solve equations that can look intimidating, but really once we know we're just doing the same thing to both sides, they're pretty easy to solve. Okay, so we're going to do some examples now. Solve each equation for the variable, show your thinking. So x to the 1/4 equals 3. So x to the 1/4 equals 3, and I want to get x by itself. So I can use putting this side to the power of 4, but whatever I do to one side, I do to the other. So I put this side to the power of 4. So x to the 1/4 times 4, because that's power to an exponent rule, would give me x to the 1, which I'll write that, but you don't really need to write that. And 3 to the 4th, if you don't know it in your head, and you can do it on your calculator, 3 to the power of 4 is 81. So x is 81. Okay? X to the negative 1/3 equals 6. So this one may take a little more thinking. So what number would I have to multiply negative 1/3 by to get 1? So a negative times a negative is a positive. But if you put this side to the exponent of negative 3, you have to put this side to the exponent of negative 3. So again, I'm just going to show this because it's the first time you've seen one of these, but negative 1/3 times negative 3. And on this side, we know we would make that 1/6 to the positive 3. That's how you evaluate a negative exponent. And negative 1/3 times negative 3 over 1 is going to give you negative 3 over, positive 3. Because negative times negative is positive. And 6 to the 3rd is 216, I believe. Yep. But 3/3 is 1, so that means therefore x is 1/216. Cool? All right, x to the 2/3 equals 16. So what number do I multiply 2/3 by to get 1? Well, 3/2. So just the plain reciprocal, or the flip of 2/3 is 3/2, and then you would get, when you keep the base and multiply the exponents, you get 6/6. But if you put this side to the 3/2, you have to put this side to the 3/2. So I've got x to the 1 on this side. Now 16 to the 3/2, actually I'll put this step in here. So keep the base and multiply the exponent, so 2 times 3 is 6, 3 times 2 is 6, just because it's the first time we've done one like this, where there's not just a 1 in the numerator. And then on this side, we know that this we can put this in radical form. So 16 to the 3/2 means the square root. So remember the bottom number from exponential equations is the root, and the top number is the exponent. We learned that about rational exponents. So we want the square root, so you don't need to show that little 2 in there, it's understood. Square root of 16 cubed. So x to the 1 is, the square root of 16 is 4 cubed. And then 4 cubed is 64. Not 12. A couple people did that on the last week. So remember, it's 4 times 4 times 4. Right, dx to the negative 5/2 equals 243. So x to the negative 5/2. So what exponent power would we have to put x to the negative 5/2 to end up getting x to the 1? So that would be negative 2/5. So if we put this side to the negative 2/5, we have to put the right side to the negative 2/5. So that's going to give us x to the positive 10/10. And here I would want to make that 1/243 to the positive 2/5. So that I deal with the negative exponent. So that's going to be x to the 1, which is what I want to know. What is x? Over the 5th root of 243 squared. So what's the 5th root of 243? So try 2 to the 5th. That's 32. 3 to the 5th is 243. So the 5th root of 243 is 3, but that's still being squared. So we're going to end up getting x is 1/9. X to the 1/3 equals 2/7. So x to the 1/3, but we ended up just getting x by itself, so we're going to put that to the power of 3. But then we have to put this whole fraction, so you need brackets around it, to the power of 3 as well. So x to the 1/3 to the 3 is just x, and this is going to be 2 to the 3rd over 7 to the 3rd, giving us 8/7 to the power of 3 is 343. All right, x to the 3/2 equals 27/125. So I want to get x by itself, so I'm going to put the left side to the 2/3, which means I have to put the right side to the power of 2/3. So x to the 3/2 to the 2/3 is just x to the 1, because that would give you x to the 6/6. And then I know I can apply that 2/3 to the numerator and the denominator. And then we can use what we learned about rational exponents to evaluate. So that means the 3rd root of 27 squared over the 3rd root of 125 squared. So that's 3 squared over 5 squared, or 9/25. Okay, x to the negative 3/4 equals 8/27. So x to the negative 3/4, but then we're going to put this side to the negative 4/3, which means we have to put the right side to the negative 4/3. And so then you would see we would get x to the multiplying fractions. You just multiply the tops together and the bottoms together, so you get x to the 12/12, which is just x. Here I would use the fraction to a negative power rule and change this to 27/8, all to the positive 4/3. So x is going to be 27 to the 4/3, which is the third root of 27 to the 4th, over 8 to the 4/3, which is the third root of 8 to the 4th. The third root of 27 is 3 to the 4th. The third root of 8 is 2 to the 4th. So we end up getting x is 81 over 16. And then h, x to the 1/5 equals 4. So we would have to put this side to the power of 5, which means we have to put the right side to the power of 5. So x to the 1/5 to the 5 would give me x to the 5 over 5, which is x to the 1. And 4 to the power of 5 is 1024. Okay, so there's our first learning goal. So that's how to solve equations where there's a rational exponent, a rational numerical exponent. All right, so solve each simple radical equation. So we're going to use the same technique. So x is the, this is the third root of x equals 7. So I could rewrite that if I wanted as using, so just changing this from radical form into a fraction. And then after I've done that, I can use the same technique that we just used. So to undo the exponent 1/3, I would put it to the power of 3, but whatever I do on one side, I have to do on the other. So that's going to give me x to the 1, which is what we want to find out, is 7 to the power of 3, which is 343. Similar with b, I can rewrite this in exponential form as x to the 1/4 equals 3. But I want to get x by itself, so I'm going to put both sides to the power of 4, because x to the 1/4 to the 4th is just x. 3 to the 4th is 81. Now they get a little more complicated, so I have to know that from rational exponents that if I have the nth root of x to the exponent m, I can write that in as a rational exponent as x to the m over n. So the third root of x squared I could rewrite as x to the 2/3. Okay, so this is the exponent and the root. But I want to get x by itself, so I want to put this side to the 3 over 2, which means I have to put the right side to the power of 3 over 2. So that's going to give me just plain x, and that's going to be using what we know about rational exponents, the square root of 25 to the power of 3, which is 5 to the power of 3, because the square root of 25 is 5, which gives you 125. All right, so this one, there's no little number in there, so we know that that means it's a 2. So I can rewrite this, because it means square root if there's no little number in there, as with a rational exponent as x to the 3 over 2 equals 27. But to get x by itself, I'm going to then put the left side to the power of 2/3, so I need to put the right side to the power of 2/3. So that's going to give me x equals the third root of 27 squared. The third root of 27 is 3, and 3 squared is 9. The third root of x is equal to 3/5. So I can rewrite third root of x as x to the 1/3. To get x by itself, I would want to put both sides to the power of 3. So I'd get x equals 3 to the 3rd over 5 to the 3rd, which is 27 over 125. And the last one, so I can rewrite this in exponential form as x to the 5 over 3. equals 32 over 243. So to get x by itself, I want to put the left side to the power of 3 over 5, which means I have to put, so use brackets, the right side to the power of 3 over 5. So x is going to be 32 to the 3 over 5 over 243 to the 3 over 5. So then writing it in radical form, that's going to be the 5th root of 32 cubed over the 5th root of 243 cubed, which is 2 cubed over 3, because 3 to the 5th is 243 cubed, or 8 over 27. Okay, so that's how you solve equations that have rational exponents and simple radical equations.